So in this lecture, what we will do is that we'll investigate deep neural networks. Now, in the deep neural network, what we will do is that we'll have a number of layers and we will add an activation function. So the first part is just preparing and importing the libraries, so there is nothing much in that. And the next part is that we are using a data set, a concrete data set, where the task is to predict the compressive strength of concrete manufactured according to various recipes. Okay, so it's starting up. So here what we do is that we read the file. So here it is, as usual, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 columns which are going to be helpful to predict the compressive strength. Okay, so these are the features. So the compressive strength is, so there are total there are 9 columns, but what would be the input shape? It should be 9 minus 1, right? Because that is the input shape, because the last one, the compressive strength, is the target variable, and the other ones, all the 8 ones, they are the input ones. So we'll check that. Yes, the answer is correct. So now we are defining a model with hidden layers. So you see, it is a very simple model. It has 512 units for each layer, and there is an activation function which is a ReLU, and there is the input shape. And the number of units at the last is only 1. So it doesn't have an activation function since we are doing a regression function. If we are doing a classification function, obviously we would have a different type of an activation function. So here we do it and it is correct. So activation layers. So we can also rewrite it using and separating the activation layers. You see, we have separated the activation layer. Here we didn't separate the activation layer. Here we are separating the activation layers. That is also correct. The optional is alternatives to ReLU. It means we can try different activation functions like TANH. We can try ALU, CELU, Swish, or something else. So this I tried with TANH, and obviously there are others which we can read about it next. So this completes the deep neural networks in which we had a number of layers and we used an activation function. Thank you.